Part 4 of magnetizing magneto rotor. Two things, well, one thing for sure that you'll need to do is to identify north and south pole, the north and the south pole, magnetic pole of the magneto rotor itself is stage one that you'll have to know. So you'll need a compass. What you'll do with the compass itself is that the needle of a compass really is a small magnet, and the point that points to north is really the north end of that small magnet. So by approaching the magnetic rotor of the magneto towards the compass, you should see a reaction of the needle. If the needle stays put when you get close to it, it means that you're getting north-south magnetic reaction, meaning that the needle itself, which is north-south oriented, usually magnetically, if it's aligned, means that it's the reverse of the magnetic poles of the compass, which is applied to the rotor itself. Meaning that right now, the way I'm holding it, my magnetic rotor is tagged as being the north field towards the compass, and the compass needle is the south end of the needle, which is pointing towards the magneto. So I would identify that side of the magnet as the rotor itself as being the north pole. So by rotating it in the opposite direction, the needle of the compass will react and turn around to now align its north end towards the south pole of the magneto rotor. This being, afterwards, what you have to do is mark your rotor's magnetic field, which I already have done. I don't know if you can see it. It's marked north here and south here. That's step one. Step two will be to the unit itself, which I am using to magnetize, is really a large battery charger with the core, the transformer inside it, which I have opened up and removed this section here, which was resting like this on it. And what you had over this section here, which is the primary winding, the secondary winding, which would charge the batteries. Once this is removed, what you'll have to do is you keep the 110 volt winding, which is the primary winding of the transformer. First, tag it, one of the leads, as positive, because it will be hooked up. It worked strictly on a 12 volt car battery. What else can I say about this? It's to make sure that, because if you reverse the polarities when you hook it up, it will also reverse the magnetic field of the transformer. So in order to magnetize your rotor, you have always to remain the same polarities because of the batteries. Now there's one thing you have to be careful. You're working with very high magnetic fields, meaning that if your finger gets caught, let's say between this thing, when you energize it, it'll crush your finger. So you have to be sure to keep clear. As an experiment or a show, I can always do this for you. You can see that it can jam your finger quite quickly. And also you try, if possible, not to look too directly at the spark itself, because it's producing UV rays, the same thing as an arc welder. Now, to identify the polarity of the transformer or your magnetizer, what I have is a small bar magnet, which I did the same principle as the magneto magnet to identify the poles of this magnet. Then I marked it. Once it's marked north and south pole, then you have identified it. What you will do, you just take a 1.5 volt battery, whatever make you want, and you put it positive to positive on your transformer. This will create a magnetic field, but not at the intensity as I showed you before. But it will allow the magnet itself, as you can see, it is now moving, and it will rotate to align itself the same way the compass aligned to it, meaning that you'll get a south pole to north pole and a north pole to a south pole. Knowing this, you mark your north pole of the magnet. It could be reversed depending on the polarity that you're putting into the transformer winding. I would suggest trying to put your polarities in a manner to receive the north pole in the center of the transformer itself. Now the next step is quite easy. What you need is two flat bars, steel flat bars, one which you will put in the center of the transformer and the other next to it, to create a north and south field between them. Then what you do is you take your rotor, which is marked north and south, and put the north field to the north field and the south field to the south field, squeeze between the two of them. If you still have a bit of magnetic field in your rotor, it will help because it will hold everything together. Now the next step is very simple. You just attach your two leads to, respecting always positive and negative, and what you do is you just make contact, hold for 3, 2, 1, 0 seconds, and it's done, and it's magnetized. And the proof of this is that, like I shown in the first installment, you can see that it can really lift the hammer. Before it couldn't. If it didn't do it, what you have to do is recheck your magnetic fields to make sure that you're really aligned north to south, etc. Other than that, well, good luck with your project, and if you want any more information, you can always contact me via the YouTube site. Thank you.